Okay, for part B, graph the following function. This is a quadratic in standard form. We have to start by finding the value of negative b over 2a. This is the x-coordinate of my vertex. I use that to build my table. So I pick two values to the left, two values to the right of my vertex. I put this into my y equals and then use the table feature of my calculator to come up with these y values. And then you just plot them and connect the dots. And we did have to label the vertex, so this middle value here was my vertex. For number 2, you have to factor and solve the following polynomial. This is a sum of cubes, so I have to use the sum of cubes factoring pattern. The a and the b, remember, are the cube root of each term, so we have 3x and 4. And then I just put 3x and 4 in for a and b where they belong. And then to solve, I have to take each of these and set it equal to 0. When I set this equal to 0, I get negative 4/3. When I set this equal to 0, I have to use the quadratic formula, which you end up getting negative 432 underneath the radical. So I made that an imaginary number there. For number 3, to expand the following expression, keep in mind when you expand, you look for division first, multiplication, and then powers. There's no division, so we break up all the multiplication. So there should be 1, 2, 3, 4 log terms now because we're expanding the 4 terms that are being multiplied together there. Then all the powers need to come out in front, and so this should be your final answer. Okay, for number 4, to find inverse functions, we first have to take f of x and replace it with y. You interchange x and y, and then our goal is to get y by itself. So we're going to add 5, divide by 2. Then we have to square both sides to get rid of the square root. And then this was plus 1, so I moved it over kind of all in one step. So you square this whole thing and then subtract 1. And that ends up being your inverse function. For 5, there's no compounding going on here. This is just an exponential decay problem because you're decreasing at a certain percentage. So we plug in 1320 or 250 for your original value or your a value. Your rate is 0.18, and we're looking for the value after 8 years. So this would be the setup, and when you punch it out, you get that value. Okay, for number 6, to graph this function, we're going to start by finding the x-intercepts, which we set this equal to 0, technically. And you factor by grouping. So we factor by grouping, this breaks down one more time. You end up getting plus or minus 3 and 5 as your x-intercept, so I plotted those first. And then in the table, you're picking the values in between your x-intercepts to find the rest of your turning points. So the point between negative 3 and 3 is 0, and the point between 3 and 5 is 4. So I plugged those both into my function to get those two y values, plotted those. Notice I changed my scale. Oops, that should be y only. And my domain range is always all reals for polynomials. Okay. Number 7. To graph this function, we label the transformations, left 4, down 2. We have to use the change of base formula here to punch out into my calculator. So ln of 1 divided by ln of 4 is 0. 2 times ln of 10 over ln of 4, because you're plugging in 10, 1, and 10. Gives me 3.32. So I graph those first, and then I have to move them left 4 and down 2. And there's my domain range. Keep in mind we use 1 and 10 for logarithms because they grow very slowly, so we have to stretch out our points. Okay, number 8. To solve this, we're going to square both sides. When you square the right side, you end up having to FOIL. Then I moved everything over to one side because I'm trying to solve, and I have a quadratic. But instead of using the quadratic formula, I noticed I could pull out a 4, so I did that. And then I noticed I could factor that pretty easily because the two numbers that multiply to get negative 3 and add to get negative 2 are negative 3 and positive 1. And so I ended up just factoring and then setting both those equal to 0. So 3 and negative 1 were my answers. And then I had to check for extraneous solutions, so I plugged 3 back in. That ended up working. You got 7 equals 7. And then I tried to plug negative 1 in, but that ended up not working, so I had to cross that one out. Okay, number 9. To write an equation of a quadratic given some information, they give me the vertex, which is hk, and they give me a point that goes through xy. I have to use the vertex form of a quadratic. And then I plug in negative 8 for y, 5 for x, 2 for h, and 3 for k. I move the 3 over, simplify that. 3 squared is 9, so a is equal to negative 11 ninths. And then I just rewrote my equation. Okay, again. Number 10, to solve this exponential equation, we have to isolate my exponential term, so I moved 1 over. And then to get rid of the e, you have to use the inverse function of ln. So I took the ln of both sides, those cancel. Give me 2x plus 3 equals ln 9. ln 9 punched out in the calculator to be 2.19. Then I move 3 over, and then divide by 2. And that should be your final answer. Okay, number 11. Just a little reminder where stuff is on the calculator. You first had to go to Stat and Edit to put all those points in your table into L1, L2. Then to get the equation, you had to go back to Stat and Calc, and the pattern that you had to plot, which we'll remind ourselves how to do that, looks like a cubic. So I use cubic regression, and then you do second L1, comma second L2, and that gets you your equation. Now, if you want to plot your points like you were supposed to do, once your data is in there, you go to second and y equals, turn your stat plot on, and then if you go to zoom, stat, it will plot those points for you. Okay. Then I had to come back here, and I took my equation that the calculator gave me, and I plotted it, and graphed it. Then I had to zoom out because it tells me to find relative mins and maxes, but I only see a max there, so I'm going to zoom out just one time. And then to find max and mins and x-intercepts, you have to use the calc menu. So there's min, max, and x-intercepts is the 0 feature. So if we were to find the minimum, ask me left bound, right bound, and guess, and then that will give me the minimum point. But if you find max, min, and x-intercepts, those should be the values that you get. Find the exact values of sine of 45, cosine of 210, and tangent of 300. Sine of 45, square root of 2 over 2. 210 is bigger than the first quadrant, so I just sketch it. It's in the third quadrant. Cosine, or the reference angle is 30 degrees, so that's when I have to use my hand. Cosine is square root of 3 over 2. Now, it's negative because cosine is negative in the third quadrant. Tangent of 300, I just sketched 300. It's in the fourth quadrant. The reference angle is 60 degrees, so tangent is square root of 3. And I had to make it negative because only cosine is positive in the fourth quadrant, and I have tangent. Okay, last page. Number 13. You're given a line. You're told that your slope is perpendicular to it. So my slope is actually going to be negative 3 halves. Perpendicular lines have completely opposite slopes, so you have to flip it and make it negative. That becomes my m. There's my point. I put it into the point slope form and simplify. For 14, we had to graph this function. My end behavior is going to be up and up because this is an even function and a positive leading coefficient. I'm going to factor this by pulling out the greatest common factor, and actually then that breaks down more. So you end up getting 0 is a double root, which means the graph is just going to touch there but not go through. And positive plus or minus 3 halves as my x-intercepts. I plot those 3 x-intercepts first. And then I know I'm going to have 2 turning points between them. So the point directly in between 0 and negative 3 halves is negative 3/4. And so I put those into my calculator. I think I stored them as x values. And then basically you're just plugging those in for x. And you end up getting negative 7.6 in both cases. So I plotted those and then connected my dots. For 15, you to solve for theta, so you had to use the trig function, sine, cosine, or tangent that relates the angle, the adjacent side, and the hypotenuse. That is cosine. To get rid of the theta, we have to find the inverse cosine of both sides, and then I punch that in the calculator to get 1.3. Oops, that's wrong. Because I just realized my mode is wrong. Sorry. That should be 74.5 degrees. Okay, and the last one, 16. You had to plot your point, draw your triangle, find the hypotenuse by the Pythagorean theorem, and then sine is opposite over hypotenuse, so negative 4 over square root of 41, 5 over square root of 41 for cosine because it's adjacent over hypotenuse, and opposite over adjacent for tangent is negative 4 over 5. Okay, I'll be here in the morning. If you need some help on any of these, but that was just a quick, brief overview. If you feel good on those problems, then you should be very set for the final.